So in this video here, we're going to be reviewing for the final exam, and you'll see that we'll start off with some problems where you're given a trig function and you're asked to find the exact value. And you'll notice that each trig function has its angle inside, and all of these happen to be in radians. And how do I know this? It's because it's written in terms of pi, and there's no degree sign either. So it's in radians. I probably need to use a unit circle to figure out what is the value. So starting with this one here, I just want to remind us, like when we're dealing with cosine versus sine on the unit circle, sine on the unit circle is representing the y coordinates, and cosine is going to be representing the x coordinate. Tangent, you might recall, is y over x, and then you have the reciprocals, which we'll talk about later. But these are your three standard ones that we mention a lot. So when I'm talking about cosine here, we're looking for the x value on the coordinate system when the angle is -3/4. So first off, this is a negative angle. So typically if we have a unit circle, let's take a look at positive. So I'm bringing this down here. Positive 3π/4 is right here. So from 0 to 3π/4, it would be in the second quadrant about halfway. So this is a second quadrant. You can see it's halfway. So if we were talking about the negative version, so we have a negative 3π/4, this would be 0, this would be negative π/2, and this would be negative pi. So negative 3π/4 would be in the third quadrant, somewhere here. So we're essentially finding the angle that is from 0 down to the third quadrant here. So if we look at our unit circle, that would be equivalent to 5π/4, which is at 225 degrees. So it looks like my x value there is -√2/2. So I'm looking for cosine value, so I am looking for the x value there. So -√2/2, and then that's it. All right, so let's take a look at secant here. So for secant, we have the reciprocal of cosine. So what I recommend doing is, like, it's hard to find secant on the unit circle because, you know, secant doesn't show up as a coordinate. So what you can do is find cosine and then take the reciprocal. So if we were to ask ourselves, what is cosine of -π/6? Well, if we go to the unit circle, positive π/6 is right here. So negative π/6 would be going backwards this way. And that would be root, you can kind of see √3/2 for the x value. So we're trying to find cosine. So it looks like it's √3/2 for cosine for -π/3. But remember, the goal is to actually find secant. So secant is the reciprocal of cosine, so all I have to do is flip this guy. And if I were to flip it, it'd be 2√3. But you can't leave your answer like this. We have to rationalize, so we'll make the top and bottom multiplied by √3. And so our true answer is going to be 2√3 over, the roots will cancel off each other in the bottom, so you just have +3, and there's no root left. And then I can't reduce this, so this would be my final answer. So 2/3 does not reduce, and that would be all that I could do. So anytime you have a reciprocal identity, go ahead and find either the sine or the cosine value, and then go ahead and flip it. Now for this one here, we have sine 7π/6. So if we look at our unit circle here, 7π/6 is going to be somewhere down here, it looks like. There we go. So there's 7π/6, and we're looking for the sine value. So sine is always the y value, and in this case, 7π/6 is -1/2. So right here, I'll write this as, let me write it in black, -1/2, and that's going to be my sine value. All right, let's take a look at our next problem here. So we have cotangent 5π/6, and so when we're talking about cotangent, it is the reciprocal to tangent. So first, let's take a look at tangent. So tangent is y over x. So cotangent would have to be x over y, is what I can think about it first. So all I have to do is take the x value that's at that angle and the y value, put them over each other, and then simplify. So if I take this here, let's go find the x value at 5 pi over 6. So if I blow this up just a little bit, we can see that 5 pi over 6 is right here. The x value is negative root 3 over 2. And the y value there is 1/2. So I have to go ahead and simplify these two values. Now it is a fraction, so maybe I'll go ahead and flip the denominator. I'll go ahead and flip this guy since I'm dividing with a fraction and make this 2 over 1. Then from there I can see that the 2's cancel because they're diagonal from each other. And so I really just have root 3 over 1, which is just root 3. And so it looks like the cotangent of 5 pi over 6 is just negative root 3. And there we go. So this kind of little note here can really help you find cotangent. So for this next problem, we have tangent, and tangent's y over x. And so we have to find the y and the x value for this angle. But here's the first problem. 15 pi over 6 does not show up on the unit circle. As you can kind of see, the last angle here is at 2 pi, and 2 pi is equivalent to, if you want a denominator 6, it's equivalent to 12 pi over 6 would be equivalent to 2 pi. So that means that if I were to write this as a mixed fraction, 6 goes into 15 2 times, but you would still have 3 pi over 6 that's left over, which is also another way of writing 2 pi over 2, because 3 over 2 is just a half, so that's why I've written it as pi over 2. So that means this guy here has already went around the unit circle one time now, and it still has about a half a pi left, which would take us right here. So that means that our tangent value right here is going to be the y value, which is 1, over the x value, which is 0. So you can see here I had to figure out where does this angle land first, and I had to write it as like a mixed fraction. You can also change this in degrees if you don't like it written as a radians. You can change it to degrees and then figure it out. But I just like to write it as a mixed fraction, then figure out where it's located. So I found my y, I found my x, put the y over the x to find tangent, and it looks like I'm dividing by 0, so this has to be undefined because we can't divide by 0. Oops, let me rewrite that, so undefined. So for cosecant here, we have 7 pi over 2, and this is also like a very large angle. And so what we can do here is either count our way to 7 pi over 2, so like this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and then this would be our angle. And so here, the x here is 0 and the y here is negative 1. So for sine, if I had to ask myself what was sine pi over 2, it would be negative 1. So I'm trying to find sine's value because cosecant is a reciprocal. So if I were to take the reciprocal of this sine value, I could put it over 1 and find the reciprocal. It would still be 1 over negative 1, which is still negative 1. So my cosecant value there is negative 1. All right, we still have a few more to go. So let's take a look at the secant value here at pi over 3. So like I said before, secant is the reciprocal to cosine. So cosine at pi over 3, if we look at the unit circle, pi over 3 is right here. Cosine is 1/2. So secant would have to be the reciprocal, so 2 over 1, which is also just 2. So my secant value at pi over 3 is just 2. Cotangent is a reciprocal to tangent, or you can just think of it cotangent being x over y, since tangent is y over x. So if I were to find pi over 3, which is right here, I would take my x value, which is 1/2, and I would take my y value, which is root 3 over 2, and divide. So I took the y value, the x value first, put it on top, and then the y value on the bottom, because that is what cotangent represents. And if I were to divide, I would have to write the 1/2 and then flip the other guy, flip the denominator. So I wrote the 1/2 down, flip the denominator. The 2's can cancel. And so this is really going to be, looks like 1 over root 3, which I have to rationalize. Might run out a little bit of space, but it's okay. So it looks like I would get root 3 over 3. So the top would end up being root 3. If I multiply the bottom, the roots cancel, so I would get positive 3. And that's it. All right, cosecant here is the reciprocal to sine. So let me pull out my unit circle for a moment here to the side. So for cosecant at pi, let me use sine first. So sine at pi is the y value. Here's pi. The y value there is 0. So if I wrote this 0 over 1 and I took the reciprocal of it, that means that cosecant would be 1 over 0. So it turns out this is going to end up going to be undefined because the 0 is in the denominator. So even though sine was 0, you can always put that over 1 and make that into a fraction so that when you flip it, you realize that cosecant can't have a 0 in the denominator, so it's undefined. That one's kind of tricky. All right, that is it for the first part of the review. We're going to get into the second part, which is over angles. So this one, instead of you finding the value, you're going to have to find the angle from 0 to 2 pi. So you will need to write it in terms of radians. Essentially what you're doing is you're given a trig function and its value, and you have to find the angle that supports that value. So we're definitely going to be using the unit circle. So this is finding what angle makes sine 1/2. Now, if we look at this here, sine is the y values. So let's make that a little note there. So sine is the y value. So if we look at all the y values, this y value is positive. So the only place that sine can be positive is up here in the first and second quadrant. And as you can see, sine is positive at pi over 6. So I know pi over 6 is one of them. So another positive 1/2 would be at 5 pi over 6. So there we go. Pi over 6 and 5 pi over 6. And that's it. So I know that I'm not going to look in the third and fourth quadrant because y's are never positive down here. So I wouldn't even bother to look. Tangent equals 1 whenever, so let's make a little note here. So tangent is always y over x. So in order to get a 1 and a positive 1, the x and the y had to have been the same number and the same signs. Well, the only time that tangent is the same, has the same x and y values is at pi over 4. Notice how pi over 4 have the same value, root 2 over 2. These are both positive. So if I were to take y and divide it by x, I would get 1. So I know pi over 4 would work. I also know that maybe at, so this one wouldn't work because they're different signs. So this would end up dividing and making a negative 1. Same thing with like 7 pi over 4. These would divide and make a negative 1. So the only one that also works is down here in the third quadrant because they're both negatives. When you divide, you'll get a positive 1. So for that one was 5 pi over 4. And that's the only one that also works. All right, let's take a look at this one here. So this one is asking where is tangent negative root 3. Now this gets a little tricky. First off, you need a root 3. So I know I shouldn't be using anything that is like pi over 4 or like 3 pi over 4, anything with like a 4 in the bottom because there's no root 3's. I shouldn't be using any of like the axes, so 0 or 90 degrees or 180, 270. I wouldn't use those because those don't have root 3. So it's either something that's like pi over 6 or something that's like pi over 3. So when I'm thinking about it, I also notice this is a negative angle, so I need it to happen to be a negative. So tangent is positive in the first quadrant and in the third quadrant. So tangent is negative in these two quadrants. So I already narrowed it down quite a bit. It's either in the second or the fourth quadrant. So perhaps it's something like 2 pi over 3, and I'm just going to try it. If it doesn't work, then I know it has to be the other angle. So if I take the y value here, because tangent is y over x, if I take tangent at This one is 2 pi over 3. That would be the y value, which is root 3 over 2. And I would be dividing that by -1/2. Let's work this out to the side here. So if I take these two values and divide, I would have root 3 over 2 times the reciprocal, which would be -2 over 1. So then the 2's cancel, which is good. And that would leave me with negative root 3 on the top and a 1 in the bottom, which is exactly what I'm looking for. So this works. So 2 over 3 is one of the angles. So I'll write here 2 over, or actually I should write 2 pi over 3 works. And I need to find an angle that also uses a root 3 over 2 for y. And that would be in this fourth quadrant. So root 3 over 2 would be right here. And the x needs to be a 1/2. And so it looks like 5 pi over 3 would also work. 5 pi over 3. So I know that it's only these two angles because I tested out this one. And I know it has to be in the second quadrant and the fourth quadrant because one of them is negative. So when I divide, I produce that negative. So same thing here. The negative is on just the root 3 over 2, and this one's positive. So when I divide, I should get that negative root 3. So this one would be the answer for number 5. It can only happen at 2 pi over 3 and 5 pi over 3. All right, so let's take a look at, oops, I guess I can't move this. All right, I got that fixed. So looking at our next problem here, this one looks like we have cosine root 3 over 2. So if we look at the unit circle, cosine has a positive value. So cosine can only be positive in the first quadrant and the fourth quadrant because x's can only be positive here. X's are always negative on the left side of the x-axis. So if we look and see the x values that have a root 3 over 2 is right here at pi over 6. And also down here at 11 pi over 6 looks like the other positive root 3 over 2. So it's almost like playing I Spy in a way. Like when I think about finding angles, I'm trying to figure out where are they located on the unit circle. And I already know the value, so I'm like searching to find that angle. Okay, so let's see if I can get rid of this. So from here I have sine and it's root 2 over 2 and it's a negative sine value. So first off, sine is always associated to the y value. So sine can only be negative down here and here. And it looks like we have a negative root 2 for y here at 5 pi over 4. So I know that's one of the answer, 5 pi over 4. And it looks like y can also be negative root 2 over 2 right here at 7 pi over 4. So those are my only two angles for y. If we check for the next one here, this is secant, and secant is the reciprocal to cosine. So first off, I think what I'm going to do first is flip this so I can figure out the cosine value because it's easier to find cosine on the unit circle because it represents the x. So if I went ahead and flipped it, kept this a negative, so I have flipped this fraction. The 3 is now on the top and 2 root 3 is on the bottom. I notice I have a root, so I'm going to rationalize and multiply by root 3 on the top and bottom. And so that would give me a negative 3 root 3 on the top. The bottom, these two 3's would cancel, giving just 2 times 3. So this here turned into a 3. The 2 just moves over. Notice that there's a 3 on the top and bottom that are both just a number. So they cancel. And so I really just have negative root 3 on top and a 2 on bottom. So I'm looking for a cosine value. Let me bring down this cosine here. That is negative root 3 over 2. So cosine represents x value. So if we look here on the x-axis, so negative x values always produce in the second and the third quadrant. And we can see a negative root 3 over 2 is right here at 5 pi over 6. So I know that 5 pi over 6 could work. Also, there's another one right here at 7 pi over 6. So these two would work, and that's the only two because this is only x values that are negative. So cosine represents the negative values, and we found two places where the x value is negative root 3 over 2. And so we found those angles. So just as a reminder, anytime you have like secant or cosecant, it might be smarter to flip it, change it to sine or cosine, it's reciprocal, and then find that on the unit circle since sine and cosine are easily found as a coordinate. All right, in the next problem, we're going to actually use equations, and we have to get the trig function by itself and then find it on the unit circle. So it's kind of like the same thing we've done before in the last few problems, where you try to find the trig function and get it by itself, and then use that value that you have to find it on the unit circle to find the angle. So you can kind of see here, we made it a little bit easier, and you just have to find the angle in degrees. Since we did the other problems in radians, let's do these problems in degrees. So make sure that you use angles between 0 to 360 and no more than that, or no negative angles either. So when I look at this problem here, you have secant right here, and so our goal is to get secant by itself. So maybe we'll add the 2 over, we'll bring the root 3 secant down, and this side is a 2, so then this root is sitting next to the secant, so I'm going to divide it off because it's multiplying it, so I have to use division. And so we have secant equals 2 root 3. Now when I look at this problem, I'm thinking, okay, secant is just the reciprocal to cosine. So at first I'm thinking like, maybe I should rationalize this and multiply it by root 3 over 3. But then I'm like, oh, but secant is just cosine. So I'll just write this instead as cosine. Oh, let me write that in black. Cosine root 3 over 2. So it's easier to find cosine on the unit circle because it's just the x value on the unit circle. So if I'm just looking for cosine, which is the x value on the unit circle, whereas sine is the y value, x values are positive. Notice this is a positive value. X values are only positive in the first quadrant and the fourth quadrant. So positive root 3 over 2 is right here at 30 degrees. So I know my x value or my angle has to be 30 degrees. And looks like another root 3 over 2 is right here at 330 degrees. So 330 degrees. And then that is it. So that would be my final answer because x can only be positive at 30 degrees and 330 degrees. All right, let's check out problem number 8 here. I'm going to zoom into this one. So for problem 8, you have to get sine by itself. So maybe trying to move the 1 over by subtracting, and root 2 comes down. This is x and this is negative 1. Then I could divide off the root 2. This would cancel. And so my sine is equal to negative 1 over root 2. I could rationalize the top and the bottom. And so this gives me sine is equal to negative root 2 over 2. So I'm looking for a value that is a sine value, so a y value. That's negative root 2 over 2. So there's only so many places that sine can be a negative value. It can only be negative in the third quadrant and the fourth quadrant. And so we can kind of see that here it's negative root 2 over 2 for y, and right here as well. So it looks like at 225 degrees and also at 315 degrees. So I'll write those two angles down. It looks like x can be equal to 225 degrees or 315. And that's it. All right, let's take a look at number 9 here. So with number 9, we have a cotangent problem. And so this cotangent here, I need to get it by itself by subtracting the 1 over. So once I've subtracted over the 1, the cotangent comes down. And then the other side is negative 1. All right, so for cotangent, you can change this. If it makes you more comfortable, you could change it to tangent. But it's kind of silly because if you wrote this over 1 and you were to flip it, you would still have -1, even if you were to flip it. So we're trying to find where cotangent is a -1, and this is actually not too bad. So remember, tangent can only be a 1 in at 45 degrees, 135, 225, and 315 because they're all the same x and y values. They're just different in signs. So anytime you have root 2 over 2 divided by root 2 over 2, because tangent is always y over x. So in order to get tangent, they had to have been the same numbers, which they are. But we want a -1. So I can't use the first quadrant because I would get a +1 if I divide. I can't use the third quadrant because they're both negative. So when I divide, I would get a +1. So I'd have to use the second quadrant version where one of them's negative, the other one's positive. So that angle right there, x is equal to 135. And then the other angle in the fourth quadrant, the y value is negative, but the x value is positive. So when I divide, I would get -1. And so 315 would also work. And I think that would be it as far as making tangent -1 or cotangent -1. All right, so let's take a look at the next problem here, number 10. So number 10 is cotangent squared. So first off, I'm going to try to get the cotangent by itself by adding the 1 over 3 cotangent squared comes down, and it's a 1. I'm going to need to divide by 3. So that would cancel. Cotangent would end up being a 1/3 here. So to get rid of a square, we learn to take a square root. Anytime you take a square root, you have to take the square root of the top and the bottom. So the 2 and the root would cancel. That would go away. Cotangent would come down. And then the square root of 1 is just 1. The square root of 3 I can't break down, so I'll keep it under root. And anytime we take a square root, we always have a plus or minus. So that means we have to consider the positive root and the negative root. So first off, this one's a challenging problem because first off, cotangent is the y over, or actually not y, x over y. It's a reciprocal to tangent. So if we were to find the angle that matches with the coordinate x and y that happens to produce 1 over root 3, we can find the angle. So first off, before I rationalize the denominator, I want to just figure out how to get the root 3 in the denominator using the coordinates. So if I want a root 3, it has to be either 30 degrees or 60 degrees because they're the only ones that have a root 3, at least in the first quadrant. So if I think about it, I want the root 3 in the denominator, and the x is being divided by y. So if I take this x and this y is in the denominator and I flip it, the root 3 would be in the denominator. So I think it's this one, not this one. So I'm going to first try out this, and if it doesn't work, then I'll go back to the drawing board. So if I take cotangent, and I know cotangent is always the x over y, so my x value here is 1/2. The y value here is root 3 over 2. If I divide, I would have 1/2 times 2 root 3. The 2's would cancel, and I'd be having 1 over root 3. So this does work. It does give me the root 3 in the bottom. So I tested it out. So this is not really my answer, but it does tell me that at the x value that I used here was 60, or the angle that I used here was 60 degrees. So it does tell me that at 60 degrees, it does produce this answer. All right. So I know 60 degree works. So I know for this angle, 60 degrees was able to give me that 1 over root 3. All right. Let's see where else it also has the same coordinate. So it also has the same coordinate here at 120 degrees. It has the 1/2 and the root 3 over 2 for y. So I know that this angle would also work at 120. Even though the 1/2 is a negative, it would work because remember, the answer that we got was either a positive 1 over root 3 or negative 1 root over 3. So we know that 60 degrees would work, 120 would work. Let's see, another thing that has an x as a 1/2 and a y as a √3 is at 240 here, where we can kind of see there is a negative 1/2 and a negative √3/2. So 270 would also work. And I think the last one here would be at 300 degrees because there's a 1/2 for x and a √3/2 for y. So 300 would also work. So for this one, there are 4 solutions. And that makes sense because this one had a square in it. So there, instead of having just 2 solutions, there was 4 solutions. All right, let's move into this one here. So this one's very similar. If I were to add the 1 over, this would cancel. 4 cosine squared would come down. This would be a 1. I'd have to divide over 4. This would cancel. Cosine would come down. This would be 1/4. I would take the square root of both sides to cancel out with the squares. And I would get the square root of 1 over, let's see, square root of 1 is 1. Square root of 4 is 2. And I need a plus and minus in front because I took the square root of a number. So always a positive and a negative 1/2. So I'm looking for when cosine is positive and negative 1/2. There are quite a few places that this happens. So if we list them out here, cosine is the x values. So let's bring this up just a little bit. Let's move this out. There we go. That's better. So it looks like cosine is the x values, and the first time it appears to be 1/2 is at 60 degrees. And then also at, so another 1/2, this one's a negative 1/2, is at 120 degrees. And then here we have also another negative 1/2 at 240 degrees. And then another 1/2, this one's a positive 1/2 at 300 degrees. And then that is it. That is all the cosine values that are positive or negative 1/2 on the unit circle. So for this last problem, we have a cosecant problem where we have to get the cosecant by itself. So I'm going to add over the 4 first, kind of like what we've been doing. The 3 cosecant comes down, and this is 4. I'll divide by 3. That would cancel. Cosecant comes down. This is 4 over 3. I have to take a square root to cancel out the root. Cosecant comes down, and the square root of 4 is 2. I can't take the square root of 3, so I'll keep it under a root. And this is a positive and a negative. Now, just as a reminder, cosecant is a reciprocal to sine, so it might be easier to just go ahead and flip this and make it a sine value. So the reciprocal to cosecant is sine. So if I flip it, it's just √3/2, which is easier to find on the unit circle. So we're looking for a positive and a negative √3/2 for sine, so the y values. So if we look at the unit circle here, the first one happens to be at 60 degrees. The second one here that has a positive √3/2 is right here at 120 degrees. And then a negative √3/2 is down here at 270 degrees. Or actually not 270, 240, because that is associating to this angle here, so 240. And then it looks like we have another negative √3/2 for y down here at 300 degrees. So definitely use your unit circle for these problems. You're definitely going to need a unit circle for the final exam, so make sure you use the handout that's been given, or you can Google unit circle. You can also look back at your notes to find a unit circle. But yeah, that is it for this part of the final. In the second part, we'll do part 3 and part 4 of the review.